Now, recently, one of Whitney's students actually presented at a professional conference on modern manufacturing and engineering. So we've invited him here to talk about his research. So please give a warm welcome to Senior Agustin Ng. Hi, Agustin.
Hi, Ben.
So do you want to start off by telling us how you got into this conference and how you got there?
So I was actually lucky enough to get into a summer internship program with Boeing. There, I was exposed to 3D computer-aided design software, NX from Siemens, and I was able to design my own parts, make assemblies, run simulations, and all that. Specifically, they introduced me to a tool called topology optimization.
Do you want to tell us what topology optimization is for all of us who aren't very sciencey?
Right, so and I actually have a diagram for this. So if we start at the left, the boring yellow part, that's going to be our initial design, and pretty much we put a simulation, run it through forces, loads, constraints, whatever we need, and then we identify elements or portions of the part that are actually useless, serve no mechanical benefit, and we just rip them right out. The end result is a part with the same structural qualities, it does everything you need it to, but with significantly less weight.
And you worked on a specific project, any specific parts?
Yeah, so Boeing had me work on a couple of satellite brackets. I think I have those here too. So on the left we have the original solid bracket, and then on the right I saved 16% of weight through topology optimization. Now you're going to notice that there's some pretty crazy curves on there. With standard machining tools and production, those are going to be really awkward to handle, but with new technologies like 3D printing especially, the weight savings can be maximized, and I actually have two models of them here. So the black here is the original model, and then the red is the optimized model, and you're going to notice all those crazy curves and such.
Now, that was the piece you worked on during your internship with Boeing, but
yeah.
After that, did you work on anything else, or was that the end of the program?
Yeah, actually, after the internship, I was able to continue my research with my mentor. This time, we were looking at what's called assembly FEM. Pretty much, when you want to do a simulation on a very complicated system, you're going to have to do it on every individual part, even if it's actually the same thing over and over again. What this assembly FEM lets us do is apply the loads and stuff onto one part, and it'll instance itself over and over again throughout the whole assembly. And we wanted also to see if topology optimization would work through this tool. And in short, because every unique position has a unique set of loads, it'll also require a unique optimization design. So it's not as simple as clicking it once and happening over and over again.
All right. Now, do you have any big takeaways from your entire experience with the conference and your internship?
Yeah, I think from all of this, it just really helped me see that there are so many opportunities out there for like aspiring engineers. And even if you're not sure you're interested, even at Whitney, there are opportunities to help you explore. For example, there's robotics clubs, STEM clubs, space set, things that you don't really have to get too invested in. And if you find yourself interested in it, you can get serious about it, and then it'll help you get into even greater opportunities. There's also stuff from the College Career Center. That's where I found my internship. And then if you keep pursuing it, maybe you'll also end up at a big conference on a boat.
Thank you, Agustin. Now, again, if you are interested in any of the stuff that Agustin is doing or interested in finding your own opportunities, go to the College and Career Center and talk to someone there and find out anything you want about what you're interested in.